Assalamu alaikum wa rahmatullahi wa barakatuhu. Dear students, hope you all are doing well. So, as the previous topic we studied about electrons and electronics, now I will be going to start with the chapter 9, magnets. Okay, magnetism. So, we all know that in the ancient time, like around 6th BC, there was in Greece, there was a farmer who went to take his he was a shepherd. He took his cattle and he was farming in some area. So in that time he was having a stick. To that stick some metal part was being attached. So when he was walking, he saw that some kind of stone has been attracted to its stick. Okay, and that farmer that shepherd name was Magnus, and he used to live in the region of Greece like Magnesia. So when he found that some stone have attracted to it, like he was wondered what kind of this stone is having some kind of special property. Then he was checking with some other types of material, he was keep on attracting it. So by this the magnet has been invented. A magnet used in our day-to-day life, in our almost all the appliances, we can say, like we have in the refrigerator we use it, in telephone we use it, and in your headphones we use it. Okay, in the, we can say, in a lot of devices, in electronic devices, electrical devices, we use the magnet. Basically magnet is, it is a lodestone. Okay, or it was named as magnetite. It has a special type of properties. Okay, so its special type of property means is attract to some of the material. There are different types of shape of magnet, we can say, like this bar magnet. Okay, a bar shape, or u-shaped magnet, or we say the horseshoe magnet. Okay, we have spherical shape magnets also. Okay, spherical, cylindrical shape, like this. There are very varieties of shape of the magnet we see in our day-to-day life. Okay, now if a bar magnet, if a bar, suppose for example, if I take an iron, like a bar of the magnet, when it is freely suspended and it allowed to come to rest, always it come to rest in a particular direction pointing to the north and the south pole, so therefore this bar magnet even have two poles, that is, one is the north pole and one is the south pole. The pole which is pointing to the south, it is called as south seeking pole. The pole which is pointing to the north is called as the north seeking pole, and the pole which is pointing to the south is called as the south seeking pole. So now the properties of the magnet. What is the properties of magnet? Okay, the properties of magnet, when two bar magnet are brought close to each other, okay, with the same polarity, means if the same pole are brought close to each other, they will repel. So we say that the like poles ripple. Okay, and if two opposite poles are brought near to each other, okay, they will attract. It means unlike poles attract. Okay, like poles repel and unlike pole attract. If suppose I am keeping the two bar magnet at a very far end, can I experience any force of attraction or repulsion on this two bar magnet? No. Means if the closer the pole, greater is the force of attraction and repulsion. If the poles are at a very far end, we cannot experience either the force of attraction or either the force of repulsion. But if the poles of the magnet or the two bar magnet are very close to each other, then only we can say that we can experience the force of repulsion or attraction depending upon the polarity. So the properties of the magnet, it is like poles repel and unlike poles attracts. Okay, unlike poles attract, and closer the pole, closer the poles, okay, greater is the force of force between them. Okay, which kind of force? The magnetic force. Which is magnetic force? Either the attraction or repulsion. Okay, so now when a bar magnet is break up into a certain pieces, suppose if this bar magnet have been break into a small pieces, always it will end up into the two pole, always it will end up into a two pole, or always it will end up into a new magnet, okay, having the pole like N, S, okay, S and N, always they will end up. Okay, so now here there are certain material which attracts to the magnet and some material do not attract to the magnet. For the material which attract to the magnet, okay, materials which attract to the magnet is called as magnetic material, and the material which do not attract to the magnet are called the non-magnetic material. So what are some what are the example of the magnetic material, and what are the example for the non-magnetic material? For example, I have this magnet, okay, in this. So when I bring near to some certain materials, like suppose I have an eraser, I have nails and pins, okay. So here when I bring to certain types of material, we will see they attract, okay. So the material which attract to the magnet, okay, are called the magnetic material, okay, are called the magnetic material. The material which attract to the magnet are called the magnetic material. But now if I see, if I bring near to the rubber, okay, or even if I bring near to the like this cap, okay, whether it will attract? No. Even now if I bring near to the spoon, okay, it will not attract, though the steel the spoon is made up of steel, but it is a stainless steel, okay. But if I bring the steel pins which is made up of purely steel, okay, they will attract. So the material which attracts to the magnet is called as magnetic material. For example, the magnetic materials are magnetic materials are like iron, okay, because magnet itself is made up of an iron oxide, okay, iron, steel, okay, then we have nickel, cobalt. This is all called as the magnetic material. Now it is not compulsory that all the metals are said to be magnetic material. For example, if we take copper, brass, zinc, tin, aluminium, they are said to be non-magnetic material, though they are also metals, okay. So we say that metals are the good conductor of electricity, all the metals, okay, means all the metals are conductor of electricity, but among that copper is the best conductor, we say. But here we cannot say that all the metals are said to be the magnetic material. No, the magnetic material are those material which only attracts to the magnet. Even in some metal, there are some metals are there which do not attract to the magnet, okay, which do not attract to the magnet, so that's why they are non-magnetic material. So what is the reason why they do not attract to the magnet? If suppose if I take an iron bar, okay, and if I take a copper bar, okay, copper bar, in the metals we are having a free electrons, or we say the sea of electrons, free electrons, okay. So this free electrons are like saturated, means they are scattered, they are means saturated everywhere into this metal part, okay. But as soon as when I bring the magnet, bar magnet, near to it, okay, when I bring the bar magnet near to it, so what will happen? This domain or this electron, they align themselves, okay, they align themselves pointing to the north direction, pointing to the north direction. But whereas the copper, the electrons which are there, this electron, they themselves act as a tiny magnet, okay, they act as a tiny little magnet, so they themselves align and they point towards the north direction. But whereas in copper, this free electron or this electron, they remain saturated, means they will not align themselves. Okay, due to that they are said to be non-magnetic material. Non-magnetic material. Okay. Now, among this magnetic material also, and obviously, like we talk about ruler, rubber, okay, so they are insulators, so they do not belong to the magnetic material. Now, again, in the magnetic material, we are said to be having the soft ferromagnetic material and hard ferromagnetic material. So what is this soft ferromagnetic material and what is this non hard ferromagnetic material? Means the material which can easily attract to the magnet or it get magnetized. Okay, when you bring any magnetic material near to the magnet, it get magnetized. Okay, so itself it will behave as a magnet itself. Okay, it will be this material will itself behave as a magnet. Okay, so here the material which can easily magnetize, it is called as the soft ferro magnetic material. The example of this soft ferromagnetic material is iron. Okay, whereas the hard ferromagnetic material is called, it is the material which is very hard to magnetize, are called as hard ferromagnetic material. Whereas this soft ferromagnetic material are used in making temporary magnet means their magnetism, they can easily magnetize and easy to demagnetize. It means their magnetism remains temporary. Whenever there is a magnet, they behave as a magnetic material, means they behave as a magnet. But when there is no magnet, they just behave as a metal, like just an iron. Okay, whereas steel is said to be hard ferromagnetic material because it is hard, they are used in making permanent magnet, and they are hard to magnetize and demagnetize. Whereas this temporary magnet are easy to magnetize and demagnetize. So that's why they are used in making temporary magnet, whereas the steel are used in making permanent magnet. The example of temporary magnet, we can say it's used as electromagnet. We will study about detail about the electromagnet in our upcoming topic.